Hello, everyone. Thanks for joining this session at the P7 user conference. It's now 10 to 11 French time, and the next paper, the next presentation is focusing on our product P7 Enterprise. Presentation is given by our president, Mr. Sergey Morozov. Sergey, the floor is yours.
Hello, everyone. It's a great pleasure to present today to this great audience. And today I will talk about digital twins and how to enable them at large scale, at the scale of all enterprises. And we will be doing this using our low-code platform, P7 Enterprise. The previous speaker already introduced the concept of digital twin, and it was a great introduction. Thanks, Bruno. But I will just very quickly remind you what it is. Digital twin is a set of interconnected computer models, whether it's a physics-based model or ML model, representing the real asset. And this is the key. There should be bidirectional link between the real asset, physical asset, and your set of computer models. And yeah, Bruno introduced a very nice term, digital mockup plus. So you start actually building your set of models, this digital DMU plus, at the early design stage of your product process or even large asset. And you can use various approaches to build your digital twin prototype. This is how it is called at the design stage. Physics-based models, as I said, or ML-based models. Sometimes it's a monodisciplinary model, sometimes it's a multidisciplinary model. And it could be even a very, very complex multidisciplinary model. But the true challenge is how to connect that to the real asset and how to use those models, which should be fast and accurate to represent certain features and properties of the real asset in order to make some predictions, in order to improve maintenance or optimize the operations. To be honest, it's pretty complicated to build a digital twin and not easy to implement even for large companies and for big experts. You need to have, as I said, models. They should be fast and accurate. You need to connect them to the real asset, to the real sensors. So you need to ensure your data is collected properly, and so on and so on and so on. And then you need to bring all that to the asset operators to make this easy to use. But even talking about the modeling part, but let's say this part, it's also pretty challenging. You need to be experts in many fields. You need to be experts in modeling, in your subject domain, in simulations, in data science, and even in software development. And the true challenge is that in even big enterprises, the number of such superheroes, as we call them, is pretty limited, and definitely, according to our knowledge, is not enough to implement the digital twin strategy at the level of the whole enterprise. Normally, as we see it among our customers, those superheroes are tasked to do everything. To do modeling, to do data science, to do the connection to the real world assets. But this is definitely hard to scale because the number of such people, as I said, is very, very limited. I put here less than 10%, but essentially it's far less than 10%. But there are other people in the organizations, as we call them, advanced users, who know quite well the subject domain, who knows simulations quite well, but maybe who doesn't know programming and automation quite well. And then there's a large population of what we call citizen users, who are just consumers of those models, who are very familiar with the subject domain, who are, let's say, asset operators or just field engineers, designers, and so on. So what's the best way to use that population of engineers which is available in the company? We believe that at least partially the solution is the low-code approach, and the split of responsibilities. We need to let those professional developers, superheroes, to focus on their sweet spots. Let's say they can, using hard code approach, build reusable components, which then advanced users can use to build the automated processes and to build those interconnected computer models using low-code approach. And then the citizen users, they can just use those automated processes and models without any coding, without any programming, in order to make decisions about their products and assets. And this is precisely about P7 Enterprise. P7 Enterprise is essentially such a low-code platform which helps you to build digital twins at scale using low-code approach. So here are the major capabilities of the platform. So first of all, it's the workflow engine, which is the visual representation of your computer model or your process. You build this using the low-code approach, starting from building blocks, connecting them, and finally building the whole model. P7 Enterprise is a multi-user environment which allows several people to work on the single workflow and allowing them to share those workflows among each other. I will speak about that later today. They can use machine learning techniques within those workflows that they're building. As I said, digital twins can be created using either physics-based model or ML-based models. Sometimes it's actually a mix of models. Then optimization could be also part of the story. Those workflows, they have to be executed somewhere, and for this, P7 Enterprise provides the powerful resource management platform which allows to execute the workflows in heterogeneous distributed environments. And finally, then this is the key thing, P7 Enterprise workflows can be considered as a web services and web apps, and those web apps and services are precisely for those citizen users, as I said before. So here, there's the screenshot from P7 Enterprise. You will see them a lot today. So what's the value of such approach? So first of all, it allows to capture and transfer knowledge between people in your organization. You can formalize and build and maintain complex multidisciplinary engineering workflows at scale, and you can share and reuse those knowledge using a low-code approach. Really, the main advantage is that you can automate repetitive tasks, because then you are building digital twins. It's not just one model. It's really a lot of models which have to be recreated from time to time, either physics-based or ML models. And through automation of such tasks, you can accelerate your product development cycle, and you can reduce your time to market with standardization and democratization. And with all that, you can enable the digital twin strategy. You can bridge the gap between engineering, because you can bring your engineering models to operations. And through that, you can have reliable, fast, and accurate models to make better and faster operational decisions. To make it very, very short, so with P7 Enterprise and with this low-code approach, you can get up to 3 times productivity gain compared to your existing processes when you work with the models representing digital twin. So now let's dive into some features of the platform. The core feature is this workflow engine and the low-code automation approach. So workflow is this. It's a visual representation of your process, how you build your model, how the models interact with each other. I think we have the most sophisticated workflow engine on the market. With it's a real visual programming environment. And second very important thing with respect to low-code approach is that you can yourself build your blocks. Actually, superheroes build blocks, then advanced users, they build workflows, and then those workflows are used by citizen users, as I explained before. So this low-code approach allows for fast implementation and development of MVPs. The logic of the process is always open and visible for inspection and revision. In our implementation, it has a flexible depth and order of automation. As I said, this low-code approach allows to accelerate the development cycle of both the digital twins and the products and assets that you are working on. All this can be done in a collaborative manner. P7 Enterprise is the client-server product. It has a centralized architecture enabling multi-user collaboration with different roles. Here you can see co-offering in real time. This is all done in browser. Collaboration here means that superheroes can build blocks and share those blocks using the central library of blocks available in P7 Enterprise. And then advanced users who build workflows, they can also share those workflows with their colleagues within the organization and through services, even in the external organization with the suppliers, for example, or partners. And this is very, very key. Then you're building the large, complex, multidisciplinary models from the building blocks to the level of workflows, and then to the level of workflow of the workflows, let's say. And for this, for example, we have a very special feature, which is pretty new compared to the last year, which is the workflow sharing by reference and link. Very important thing is that all those engineering work is done not in isolation. It is done in the larger IT context of the organization, and thus P7 Enterprise has to offer interoperability with other IoT platforms available in the company. So here are just some examples of platforms with which integration has already been implemented. So for example, you can glue it together with Teamcenter and ARIS as a PLM platforms, or with SPDM platforms like PDTech. Today you will see this in action, or as it was already announced with Splunk as an IoT platform. This is all done through the set of APIs which allows bidirectional communication between P7 Enterprise and those platforms. And the second, and maybe more importantly, is that you can build such integrations, such interoperability stuff yourself. So you can build this either at the block level, or you can build it at the workflow level, or you can build it at the apps level, as I will show you this later. I already mentioned that P7 Enterprise is the cloud-native platform, so it can be deployed on premises, but it can be also available as a SaaS on our managed infrastructure. Most of our current deployments are on-premises deployments, and the software is tailored for that. Here's the list of platforms we support for managed cloud deployment. I already said that P7 Enterprise has a very sophisticated workflow execution engine, and to enable this, we have developed a special resource management capability, which allows to manage HPC workstation and even external, as we call it, external Windows machines. This is there some special software can leave. All in all, this gives the following capability. So many users can execute many workflows which consist of many blocks on a distributed heterogeneous environment, and this all can be done in parallel. This is a very, very key difference compared to our previous generation of products, P7, which was a desktop product. This also all allows you to scale your computing power and to scale your models quite easily. You just need to connect more resources to P7 Enterprise deployment. In order to build fast and accurate digital twins, you need to glue together physics models and machine learning models, and for this, P7 Enterprise offers industry-proven P7 core algorithms embedded either through Python scripting at P7 core level, or through dedicated blocks like design space exploration block, or you can use your favorite machine learning tools as you like through Python, or you can wrap them in your special blocks. As I said before, this is the task for superheroes. And for this, you can achieve unprecedented performance in your hybrid digital twins. These custom blocks can be put into the workflow level, or it can be put to the central library of blocks available on P7 Enterprise. Here are the list of software tools for which some of our customers have already created connectors, but believe me, the list is much larger than that. and you can make those tools available as a special blocks with custom UI within the platform. So your advanced users or even citizen developers can easily use those tools in a very, very special manner. You want them to use those tools. So for this, you achieve standardization of usage of your simulation and ML tools, and you extend the P7 enterprise capabilities pretty easily. In order to fully democratize the approach, the advanced users can build what we call web apps for citizen users. Every workflow can be easily converted into the web app just in a few clicks. So you just define the inputs and the outputs of your workflow, and those inputs and outputs, they become the fields in your app that user can fill in and read the results from the outputs. You can go further. You can fully customize the web app UI. Of course, this requires certain skills, and this is the work for superheroes. But we see quite often that our users do that in order to fully democratize the certain simulation or the certain model. All those web apps, they live in a special place which we call Apps Hub. It's a gallery, let's say, or the app store of workflows and some end models. And essentially, those workflows can be also considered as services living in the Apps Hub. So Apps Hub also works as the place where you manage and orchestrate your services accessible, for example, through the REST API. So those, let's say, services are not just for people like citizen users, but also for other software tools, other IT platforms. And this is how we bridge this gap between digital twin prototypes and digital twins instances. So the models living in the Apps Hub, they can be considered as instances of your digital twin prototypes connected to the real asset. And in order to orchestrate them, we offer certain service orchestration capabilities. As already mentioned, there is this REST API for this, and also certain graphical capabilities to manage runs and results and to see who, when, and how executed the models. Bruno already did a great job representing this concept of hybrid digital twins for me. I will just say that in order to build a really fast and accurate digital twin, you need to glue together physics-based models and ML-based models. And for this, you can use our low-code approach. Moreover, this is often not a single shot, let's say, task. You need to build and rebuild and retrain those models from time to time. And for this, P7 Enterprise automation capabilities offer great flexibility and great performance. You can create, for example, you can build the workflow to create the model, to validate the model, to deploy the model as a service, and actually the whole workflow becomes the model as a service which you manage in the Apps Hub. Yeah, this is more or less it. Your physical asset becomes connected to the workflow-powered service, let's say a model as a service. So you can stream your live sensor data to that workflow. That workflow will process that data using physics-based models, so ML-based models, and it will send the feedback to the real asset. Actually, it doesn't really send it to the asset itself. As I said, digital twin is a pretty large and complex concept. This all has to be considered as part of the global, bigger stack of technologies. So you have the sensors, you have your data sources, you have the data hub there, you store those data. And then there's the P7 Enterprise layer, which uses this data as a source of information for your hybrid digital twins. And then it sends the data to the business application layer. There you visualize, for example, and process that data. And then the decision goes down in this stack. So the decision is made here, then it goes through the model to the data storage and then to the equipment. This is just one example how it could be implemented. Today you will see it in action. Let me conclude. So what are the benefits of usage of P7 Enterprises and the whole low-code approach essentially? So first of all, and maybe we can even stop here, it's the productivity gain. With this low-code approach, you can achieve significant productivity gain in building and deploying your digital twins at scale. And for this low-code approach is very essential. So you need the flexibility to enable superheroes to build blocks and advanced users to build workflows and citizen users to use those as models and services. So all in all, it gives you better designs of your products and better operations of your processes and assets. Today, you will see several examples how this works in live and in action. But that's it for me. Thank you. If you have any questions, I'm here to answer.